Yes,
Yes,
ma'am.
ma'am.
Okay, and in electric potential, have you done any questions in this? Have you started with any questions?
No, ma'am. I haven't.
Okay. I'll just start with the basic question, so then he can continue, because there's a pattern that you all have to follow. And if I start to teach something else, and see, it will be difficult for you to cope up. So I'll just start with the basic questions which have already come in JEE and from your chapter 2 itself. So electric potential and capacitance. Okay. Now in this chapter, basic formula, everything known. Basic formula you already know. So firstly, you have the concept of work done, which we have already studied. So this theory portion, I know you both already remember this. So what we are going to do, question and answer practice only. Practice session, let's do. Let's see from the previous year's question, how many questions you already know, how many you are able to start. So basically today's topic will be electric potential portion only. We'll be focusing on electric potential only. We don't know the concept of work done and all. We will not try to go to energy. First concept, electric potential, which we have studied, that we'll try to stick to it. So yes, what is the, before we start with anything, you should know what is the generalized formula for potential. Yes, anyone? For a charge Q, radius R, what should be the potential?
WQ.
W by Q.
W by Q. W by Q is in terms of work done. For an individual charge, it is KQ by R. Work done, this is for potential. This is particularly for potential. This is just particularly for potential. And when we are talking about work done, then you have the concept work done and the concept of potential, then it gets related. When we are talking specifically about work done, then you have this concept of charge being multiplied to the change in potential. That is, we say the charge final potential minus initial potential. But this is very important for your JEE. This formula is very important. And more in most of the cases, you will see it is written as Q by 4 pi epsilon naught R. Complete full formula. Why? Because 4 pi epsilon naught plays a significant role when you have a question. So let me write down, you can write down that this will just take a minute to write, but let me write down the question also first. Then you can copy the question, try the question by yourself, and then we can have a discussion. So I'll start with a very easy question. So basically this says that do not write down right now. 512 identical drops of mercury are charged to a potential. So complete potential for all these drops, 2 volt, means for a single drop, 2 volt each. Now all these drops are coalesced. So the drops are joined to form a single drop, means a big drop. Now you have to tell the potential of this drop is dash volts. This is a question from 2021, 25th Feb, shift first. So I'll give you the options also, so it's better for you to at least try it. So option A, or let's leave this because it was options weren't given, so let's also leave this. Write this down. Then you can write down the question and then we can discuss it. So look, here in this question, what we are going to do, let's say number of mercury drops, how much it's given? The number of mercury drops are 512. So let's say number of mercury drops, these are 512. Now, voltage of each. This is 2 volts. Now see, when let's assume that small r is the radius of the small drop and capital R is the radius of the big drop. Okay. Now, if these are the radii of the spherical drops, we have to join all the small drops to make the bigger drop. But one quantity that will remain constant will be volume. Volume cannot change. If small drops are present, and you are joining it and making it a big drop, so volume will still be the same. So it means 512 times the volume of each small drop. 4 by 3 pi r cube. This will be equal to 4 by 3 pi capital R cube. Okay. So 4 by 3 is cancelled. R cube is equal to 512 small r by 2 whole cube. Let's take the cube root. So this becomes r. This is 8. This is small r. So this is the relationship. So we know the voltage of the smaller one. V is equal to kq by small r. This is equal to 2. And the net voltage, that is the voltage of the bigger drop. This is kq divided by r, capital R. So if we are talking about the total net voltages, see K, what is the total charge now? The charge of a small droplet with radius r, charge was q. Now 512 times this q is present with the radius r. And what is capital R equal to? 8r. So we can say, if you separate the term 512 by 8 into kq by small r. What is kq by small r equal to? 2 volt from here. So 512 by 8 into 2. So this is 4. This is 128. This will be the answer. Write it. Then some other questions we will see. Right, this question, it says that 10 charges are placed on the circumference of a circle of radius capital R with angular separation between successive charges. Alternate charges 1, 3, 5, 7, 9 have charge plus q each, while 2, 4, 6, 8, 10 have charge minus q each. The potential V and the electric field E at the center of the circle respectively are that we have to tell. And it's a question from 2020. 5th September, shift 2. Okay, so see, in this question, the best way to solve is, see, you have to solve every question in a very small duration of time. So in this question, the best method is that you draw the circle. Because the charges are not unlimited, they are not infinite. You know there are 10 number of charges given. Now what you do? Now you start marking the charges. This is 1, this is 2, third charge, fourth, fifth, sixth, seventh, eighth, 9, and 10. All the charges are present. Now let's put the values of each charge. So this is plus Q, this will be plus Q, this is plus Q, and 7th is also plus Q, 9th alternate, these are plus Q. Now see what are left. These are this is minus Q, this is minus Q, this is minus Q, this is minus Q, and this is minus Q. So basically, if you have the center, which is the center C, and you have to calculate all the charges, all the voltages, all the electric fields, the answer is very clear. See, firstly, when you are calculating the potential at the center, due to 1, it will be kq by r. Second, it will be minus kq by r. Then third will be plus kq by r. Fourth will be minus kq by r, and so on. So if even numbers are given, if you see in your question, even numbers are mentioned and they are placed on the circle. So see, circle is what type of figure? Circle is a symmetrical figure. So if it's a symmetrical figure and you see even numbers are present, because in case of even numbers, all of these will be cancelled. So you get a complete zero potential. Okay, this is a complete zero of potential. And when we are talking about electric field, same thing due to electric field also. When you are talking about electric field, then also see electric field due to the plus Q charges, this is 5 times the net electric field, and then plus 5 times electric field due to the minus Q charges. So this is 5 kq by r. And when you will solve this, this is also one vector which is, see, it is like plus 5 kq by r, but in the opposite direction. So this is exactly, if this is, let's say I cap, so this will be minus I cap. This will be exactly in opposite direction because of the net vectors. Here it was very easy because all these quantities, in all these quantities, it was a scalar quantity potential. But since electric field, it's a vector, but you know that ultimately one direction will be towards one side, or it can be upwards or downwards also. That is j cap and minus j cap also. That's not an issue. This is I cap and minus I cap. That's not an issue. So electric field will also be Z. Write it down, please.